Hey everybody, we are continuing the Pre-Cal 8.1 video. So the first thing I want to do on this one is identify what we know if that's the reference angle. So this is the opposite, this is the adjacent, this is the hypotenuse. So before we do anything, we're able to do the opposite over adjacent, which means we're able to do the tangent. And so that's square root of 11 over 2. And so that's that answer. And then we're also able to flip that, because for cotangent, it's 1 over tan. And so we could say 2 over square root of 11. That's what I would put. Or you can rationalize that. Get 2 square root of 11 out of 11, which is the same. So you're able to get 2 answers automatically just from the numbers given. Now, we have to do the Pythagorean theorem, but I bet that we would do 2 squared plus square root of 11 squared, so that's 4 plus 11 is c squared. So 15 is c squared, so c is 15, square root of 15. C is 15. Okay, so then that means that the sine would be the opposite over the hypotenuse, which is square root of 11 over square root of 15. Now, it doesn't look like that, but that's because they rationalize it. So if you have square root of 11 over square root of 15 and multiply by square root of 15 over square root of 15, you get 15 in your denominator, and then in your numerator, it would end in a 5, and it's 165. So I would prefer this way, but if you want to rationalize it to make the paper match, you can do that. And then remember that cosecant is 1 over sine, and so that'd be the square root of 15 over square root of 11, or you can even say 15 over square root of 165, or you can go further. I'm going to say square root of 15 over square root of 11, and then multiply by square root of 11 over square root of 11. So I get 11 on bottom, and then the square root of 15 times square root of 11 is a square root of 165. So that's how that works. So again, sine goes with cosecant, tangent goes with cotangent. If you remember, sometimes cotangent was 4th on a different assignment. So just make sure you know your definitions. CSC goes with sine. Color-coded if you want to. Okay, the next thing is the cosine. So the cosine is the adjacent over the hypotenuse. So that'd be 2 over square root of 15. Again, I'd take that. On Math Excel, it would accept it. You could also multiply by square root of 15 over square root of 15 to get 2 square root of 15 over 15. And then cosine goes with secant. This is 1 over cosine. So you could just flip this one, which is why I like the unsimplified form, and you get square root of 15 over 2. Otherwise, if you flip 15 over 2 square root of 15, then you'd have to multiply by square root of 15 over square root of 15 to get 15 square root of 15 over 15 times 2, which is really 30, but I left it that way for a reason. Then you cross out that, and so then you get square root of 15 over 2. Now again, notice it's 2 times square root of 15 times square root of 15. If you have 2 of the same thing underneath the square root, then just the square root goes away. And so it's just the number. So that's how number 5 works. Now on this one, it looks like it's going to work where you just use your calculator and make sure you're in degree mode. Degree mode or degree symbol. Okay, so at the moment I am in degree mode, and so then I do sine 77 over cosine 13. Okay, so that just gives me 1. So that's it. Now, if I go to teacher mode, does it change anything? No, it doesn't. Now, what this is really about, it's about the co-function. So basically, we said if you have sine 77, then this would be, let's go back to our notes. Cosine of 90 minus 13. So that means sine 77 over tan 77. I'm sorry, I just got ahead of myself. Sine 77 over cosine 77. And if you have sine over cosine, let me just rewrite that. Sine 77, cosine 77. That means tan 77. So what if we did tan 77? Oops. Okay, it's early in the morning. Sorry about that. Obviously, I can't do this. I can't say cosine 13 is the same as cosine 90 minus 13. What I was trying to think of was sine 77 over. Now, 13 is the same thing as 90 minus 77. And so I was trying to do it clever and say cosine of 90 minus 77. But that doesn't really buy us anything, but you would get the right answer that way. Oops. 90 minus 77. That gives us 1. So that didn't really help us too much. But here's one thing I can tell you. If it wants exact and if it has random numbers that are not on your unit circle, then it better be either 1, 1/2, square root of 3 over 2, or square root of 2 over 2, or 0. These could be possible answers. And remember, this decimal was 0.866, this decimal was 707. Now you might have multiples of those also, or multiples. So what I mean by that is like 2 times it or whatever, depending on what quadrant you're in. Okay, now on this one, 1 minus parentheses cosine 46 squared. Look at how I had to do that. The 2 is in the middle on the paper, but I had to put the 2 on the outside. On the calculator. And now I need a minus cosine 44, all of that squared. And so I get 0. Now this one probably, like, if you did the work, which I know you probably don't want to do, but it'd be like 1 minus 1 if we work backwards. And so then this would be something like sine squared x plus cosine squared x. Okay, well, what if it were rewritten? So this is what I was trying to do earlier, that cosine squared 46 is the same thing as sine squared of 44. That's what I was trying to do earlier. And that means I could change this to sine squared 44 minus cosine squared 44. I need a plus there because I factored out the minus. So that's how this would make sense as far as like working backwards if your calculator doesn't give you your answer. So earlier when I was like messing around a little bit with this, the other way to think of this is sine 77 over sine 77. And so that's how that just cancels and becomes 1. Because sine 77 is the same as cosine 13. I can even show you like in the teacher calculator. Sine 77 reduces to cosine 13. Now what y'all would probably do is just get the decimal of this one, and they match. So that's what I was trying to do earlier, but now it's all cleared up. Okay, now on this one, what do we know? We know B is 19 degrees, and we know little b is 4. Now, that's the only side we know, so you can't use the Pythagorean theorem. Yet, because you only know one side. So what we have to do is you have to set up things with, to get A, you're going to have to do opposite over adjacent, which is tangent, and we say tan 19 equal 4 over A. Now, when your variable's on the denominator, you multiply by A and you divide by the other. In other words, the shortcut is just they switch places. They switch places. Let me write out more work for that. You multiply by A, you divide by tan 19. So you end up with this. And so 4 over tan 19, 4 over tan 19 is 11.6168. So if we round to the 100th, we get 11.62. Now I'm going to do a little test. What I would prefer on C is if you do opposite over, let me just draw an arrow. For C, let's just try it with trig, which is the opposite over hypotenuse. And so that's sine 19 equal 4 over C. And so C equal 4 over sine 19. 4 over sine 19. That gives us 12.286. And so that's why we round that to 12.29. Oh, and also let me go ahead and get before I try it a different way. If I know a 90-degree angle and if I know these two angles are complementary angles. They add to 90. So you can say 90 minus 19 and you get 71. Now what I wanted to try, because I think it's going to be a rounding issue, try the Pythagorean theorem. So second approach, Pythagorean theorem after getting one side with trig. So let's try that. We're going to have 4 squared plus, we said A is 11.62 squared equals C squared. 4 squared plus 11.62 squared. So that's 151.0244. And then if you do the square root of that answer, you get 12.289. In this case, it would round appropriately to 12.29. What I was trying to show is that it wouldn't work. Isn't that funny? I was trying to say it'd be better to use 4 squared plus 11.6168 squared. 4 squared plus 11.618 squared. That gives me 150.9779. And so then when I do the square root of that, I get 12.287, which does end up rounding to 12.29 in this problem. What I was trying to show y'all is if you miss a problem and if you're off by 0.1, it might be because you didn't use the exact answer. And it's better to not use the Pythagorean theorem because you might be off by 0.01 and then miss it. That's what I was trying to show. Now on this one we have little a is 5. Capital B is 50 degrees. And then we know the right angle. Like when I was teaching this without using worksheets, I did A equal, B equal, C equal, A equal, B equal, C equal. I mean, I did it like that, but you have blanks. But what we do know is this could be found really easily, and you can do 90 minus 50 and get 40. And so that's that one. You can get that really easy. Anytime you know the 90-degree angle as well as one angle, you get the other real easy. Now, to get B, we're going to have to use this, and here you go. Are we going to be able to use C, like B over C? Like, can we do sine 50 equal B over C? No, we can't. We have to use the 5 because you have to use one of the sides you know. That's the whole point. You must use the given side. You cannot do sine 50 equal B over C because you're not using the 5. So how we have to do it is we have to use the opposite over adjacent in this case, which is tan. Tan 50 equal B over 5. Now, this is different than what we did before when the variable was on bottom. Here the variable's on top, so we just multiply by 5. And don't multiply it to your angle, you multiply it like 5 tan 50. 5 tan 50. That's 5.9587. Well, that's going to be 5.96. Okay, and then for the other one, we're trying to get C, so now you do need to use A and C. So if you're using A and C, that'd be the adjacent over the hypotenuse. So that'd be cosine 50 equal 5 over C. Now this time C is on bottom. That's why you got to watch out. It makes you pay attention. So then we'd say C and cosine switch places, multiply by C, divide by cosine 50. So 5 over cosine 50 well, it reduced to 5 over sine 40 because I forgot to press Control Enter. 7.778. 7.778. So that's 7.78. Which are that? Okay. Okay, we're going pretty good. But let's see, 10, 11, 12. There's still a lot of problems left. That's going to be all for this video. Okay. You probably just do this one the same way, and same thing on this one. You know, I'm going to go ahead and go with these two real quick. Okay, B is 9, A is 10. So to get little a, I'm going to do opposite over adjacent. So that's going to be tan 10 equal A over 9. So this time you do 9 tan 10. 9 tan 10. 1.586. And then for this one, I'm going to use the 9 with the C, so that's going to be adjacent over hypotenuse. And if it's that, then that'd be cosine 10 equal 9 over C. This time C is on bottom, so you do 9 over cosine 10. .138. So that's your 9.14. And then to get the other one, it was just 90 minus 10 to get 80. Okay, like on this one, let's go ahead and do this. 90 minus 15 to get 75. Okay, so what do we know? We know A is 6. We know capital A is 15 degrees. And we know that's 90. So if we're trying to get B, then we've got to do opposite over adjacent. And that's tangent. Tangent 15 equal 6 over B. So then we multiply by B and divide. So it's 6 over tan 15. 6 over tan 15. That's 22.392. So that's 22.39. And then for the other one, if we're using the 6, we're doing opposite over hypotenuse, which is sine. So we're doing sine 15 equal 6 over c. If c's on bottom like it is, then we divide 6 over sine 15. $23.182. On this one, we don't know two angles. This really is a good stopping point, so I'm going to stop right there for this video. Hope you have a good day.